So in the previous lesson, in the last example, I realized that I made a mistake. I copied, or I wrote a different number than I should have. So one of the series that I copied from the formula sheet, I just put 2 instead of 3 here in the first term of x squared, and I carried that 2 later on in the example. So it's c squared over 3. And so let's just do that last example one more time so we can fix that. So the last example was to come up with a Fourier series for 2x minus x squared, the Fourier cosine series. Which means we plug in the Fourier cosine series for x, given here in the interval 0 pi. And then we subtract the series for x squared, where we replace c with pi, because we have to have it in the same interval, right? So c equals pi, so that becomes pi squared over 3 plus 4 times pi squared over pi squared, summation from 1 to infinity, minus 1 to the n over n squared, and pi x over pi. So pi cancels here inside the cosine. Pi squared cancels here. Then you can move inside the constant, because then we can combine those summations, right? So the constant terms is 2 times pi over 2 coming from here, and then the other constant term from the second parenthesis. And then, so actually there's 2 times 2 over pi in the first. So when we combine the summation, we have 2 times 2 over pi, so that's 4 over pi, and then minus 1 to the n minus 1 over n squared. That's from the first parenthesis, and then here we have 4 inside the summation, so that's going to be minus 4 minus 1 to the n over n squared. All this multiplied by cosine of nx. We can leave it at that. You can maybe write it as a single fraction here, but that's not necessary. So basically, if you were to match it with the standard form, the way we write in the standard form the cosine Fourier series, basically a naught over 2, the first term is going to be pi minus pi squared over 3, and this guy here will be an. All right, so that's it for this correction.